Okay, so what we have here and the examples on this video are going to be where there's different trig functions. We can't factor using like the quadratic method while it's in this form, but what we can do is use our Pythagorean identities or something else to convert it. So let's do that. We know that sine squared plus cosine squared equals 1. Let's move that around. And let's do some substitution. So this will substitute for this. All right, now it's all in cosine. We can distribute, combine terms, do all that stuff, and we can get this to something that we can deal with. So combine the positive 2 and the negative 3. And we don't like factoring when there's a leading negative sign, so I'm going to divide the entire equation by a negative 1, giving us 2 cosine squared x minus 3 cosine x plus 1 equals 0. Okay, now this is in quadratic form. They're both the same one, and we can now factor this into 2 cosine x minus 1 and cosine x minus 1. Like I've been saying, if you're not sure and you're not sure if this is correct, take the 10 seconds and FOIL it out and verify that you have done this correctly. It doesn't take long to check, and that's what's going to make sure that you get this correct. Anyhow, now we'll split these up and solve them both. And by solving this one, cosine x equals 1/2. So in the 0 to pi over, or to 2 pi, our solutions would be pi over 3 and 5 pi over 3. All right, this one. So in that same interval, your solution here would be x equals 0. So our solutions for the entire thing, the infinite solutions would be pi over 3 plus 2 pi n, 5 pi over 3 plus 2 pi n, and just 2 pi n. That goes with the 0. And remember, that's where n is an integer. All right, so there's our solutions for that one. So we will find some way to rewrite these so that they are all in the same form. All right, next one up is cosine x plus 1 equals sine x. All right, same thing. We have cosines and sines. What do? We need to get them to be the same thing. Sometimes you could factor, but nothing's going to factor here. So what do? We're going to actually try and square both sides. Oh, by the way, I wanted to mention, this is just solutions in the interval 0 to 2 pi. So sometimes it'll specify the interval where to find the solution, sometimes it won't. When it does not specify, we need to use that other notation. Here, once we find our regular solutions, we are good to go. All right, so I'm going to try something a little different, because we can substitute sine and cosine when they're squared, but when they're not squared, we can't. So we're actually going to square both sides of this equation and see what happens. You're going to see it's going to work out nicely. If I FOIL the left, cosine squared x plus 2 cosine x plus 1 equals sine squared x. And from the above equation, I know that I can replace sine squared x with 1 minus cosine squared x. Now, I'm all in terms of cosine. I can move the cosine over, I can move the 1 over, I can do everything now. And if I add the cosine squared x over to this side, I'm going to get and now if I subtract the 1 from both sides, I'm going to get a 0. Because when we factor, we need it to be equal to 0. All right, this is now factorable. I'm going to take out a 2 cosine x, leaving behind in the first term a cosine x, and leaving behind in the second term just a 1. All right, now it's factorable just like, well, it's factored already. Now we're going to split it up and solve. 2 cosine x equals 0, cosine x equals 0. When is cosine x equal to 0? That's at pi over 2 and 3 pi over 2. All right, let's split this one off and solve this. Cosine x plus 1 equals 0. When is cosine x equal to negative 1? Well, that's at pi. All right. Now, one thing that we do have to do that's a little bit different on this one is because we squared both sides, you know, when you square both sides, you can actually, like, because you know when you square root, you get a plus or minus, and when you square, it's always positive. So that whole, like, plus or minus, then always positive thing could create an extraneous solution. So we have to check for extraneous solutions. Only because we squared both sides. If we wouldn't have squared both sides, we wouldn't have had to check. So we're going to plug them all in. So first let's plug in x equals pi over 2. And that will be cosine of pi over 2 plus 1 equals sine of pi over 2. Well, cosine of pi over 2 is 0 plus 1. The sine of pi over 2 is 1. So this one checks. This one is a solution. All right, next up, we have x equals 3 pi over 2. Let's see, cosine 3 pi over 2 plus 1 equals sine 3 pi over 2. Let's see, cosine of 3 pi over 2 is 0 again. Plus 1 equals sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1. Does not work. This is not a solution. This is extraneous. All right, the last one here is x equals pi. So cosine pi plus 1 equals sine of pi. Is it true? Cosine of pi is negative 1 plus 1. Sine of pi is 0. That checks. And pi is also a solution. So this solution was extraneous. Okay, so the reason we have to check once again is because we squared both sides, it can create the extraneous solution. There's only certain moves, certain steps in solving that can actually create that. This is one of them. All right, one more example. We're on a little bit of a time crunch because I have to keep these videos under 15 minutes. And the first time I recorded this, I went over. And it's actually not so bad because I can't figure out how to let YouTube, how to make YouTube let me upload something longer than 15 minutes. So if any of you can figure it out, I mean, I read the things to do it. I don't know. The buttons don't match up, but whatever. So if anyone can help me out, by all means, send me a message. All right, anyhow, same thing we did before on the first example. I have a conversion between secant squared and tangent squared, so that is 1 plus tangent squared x equals secant squared x. So I can do some lovely substituting right here. So 1 plus tangent squared x minus 2 tangent x equals 4. I'm going to move the 4 to the other side. It's going to be negative. I'm going to add in the positive 1, and we're going to get tangent squared x minus 2 tangent x minus 3 equals 0. I threw 2 steps all in there. All right, now just like the other one, factorable and solvable. Let's factor. So tan x minus 3 and tan x plus 1 equals 0. Let's split it up and solve. Okay, so real quick, I'm going to do this one first because this is the easier of the two. This one, when is tangent of x equal to -1? That is actually going to be, and once again we're looking in just that interval, negative pi over 4. That one we get right from the unit circle. That one's not an issue. But this one is a little bit of an issue because there's nowhere where tangent of x is equal to 3. Now it does happen, the tangent of x can equal 3, but it's not going to be one of our nice answers, the pi over 4, pi over 3, or any of those. So because it's not going to be a nice answer, we actually have to solve this for x by doing this. Arctan of 3. So for all of the values that we've done up until this point, we've gotten nice answers because they've been unit circle values. This is not a unit circle value. That doesn't mean we can't solve it. That just means our answer is going to be ugly. So we're going to leave it in this form. We're not going to get that into the decimal. We're just going to leave it like that. And we're going to write our answers just like we've been. So x is equal to arctan of 3 plus pi n, just like before, and also negative pi over 4 plus pi n. Remember, this is a tangent function, so that's why we're just doing pi instead of 2 pi. Anyhow, where n is an integer. Okay. So the only difference here is because there wasn't a value of tangent where it's equal to 3. That's one of our nice angles. So because of that, we just have to use the arctan to solve it, and we have to keep it in that form. If we needed to, we could obviously just plug that right into the calculator and get the answer. Okay, that's all. Try the example or the sample questions. I have them posted on Schoology and submit them. Remember, if you can, keep submitting through Schoology. It just keeps everything very organized. If you can't, then go ahead and submit through Remind if you have to. All right, thank you.